This is Code.org. A pizza truck keeps track of the number of pizzas a customer orders in a list that is sorted from smallest to largest. Perfect. That's perfect for a binary search. In pizzatruck.java, write the method search for order to find a custom order with a customer order with a specified number of pizzas. In orders, list an iterative or recursive binary search. Return the index location of the food quantity. All right, so we have an example of both an iterative and a binary search already in this lesson. If we go back a bubble, or we go back to lesson 3, we have an example. Here's an iterative one. That's my example of a binary search. Let me head back though. And here's a non-iterative one. I can go ahead and remove this. So I'm going to go ahead and do the iterative one or the recursive one, I'm sorry, since that's the lesson that I am in. I am going to be borrowing their entire binary search. Copy. And we'll have to modify it. It's not going to just work by throwing that in here, right? And so let me go ahead and let's see. Actually, I don't think I want the whole thing. So let me go ahead and grab this part of theirs. Control C or Command V on a Mac. Okay, and so what's a binary search do? Well, we are splitting a list in half, right? We're splitting a list in half. What's a binary search do? Let's do a quick refresher. Binary search, I'm searching for 27. This is my handy dandy example. I grab the index 0, left index, and the high index or right index, 9, and the middle index, 18, or 4, right? And so then I check the middle index, which I got by adding the low index and the high index, the left index and the right index together. And 0 plus 9 divided by 2 is 4.5. Int converts it, drops the decimal, so 4. 18 is less than 27, so we throw out this half. And now we move the lowest to middle plus 1, so lowest is 5. High is 9 still, and the middle is 7. 54 is greater than 27, so we throw out this now, so on and so forth. That's our binary search, and that's what we need to do here now. So what's different? Well, first of all, this is an array list of orders, whereas the example they originally gave us, the recursive one, which is the one I am using, is an array. So I need to be really careful about switching all of that out for starters. I'm going to go ahead and replace numbers with orders, and this needs to go. And instead, I'm going to do orders, and remember we use .get for an array list. Left, right. Oh, interesting. So they originally set this up to be iterative, but then they're allowing us also to do recursive. So I'm going to show you an example of both. And is this double? Yes, or an int. Let's see, pizza truck add order. It is an integer. That looks good. That looks good. Let's see if I broke it. Oh, I left it binary search. That's not what we have. We have a search for order. Whoops, and I still have this quantity. So we need it to be the array list. Actually, we don't even need to include the array list in this because we know what it is since it's all part of this class. So I'm actually going to get rid of that part of this. That all looks good. Now, let's see what else I broke. Oh, search for order 10. That's funny. So I need to give it a low and a high now. Oh, interesting. So they made it hard to do recursive. Since they're not allowing me access to the length, I'm going to do a -1 and then say, let's see, left, right. I mean, I know the length of this technically. I could put in the length. I'll do that. So the length is 6, and then my target will be, I don't know, 7, sure. Oh, they had a target of 10, I got it. Index 0, 1, 2, 3, 4. Great. And so that's the recursive route. Now let's go ahead and take a look at the other approach. And I just magicked my way over to their example of this form of a binary search. I am going to just copy. Boop. Code.org gives us Control C, a lot of resources. Why not use them? So this is my original search for order now. And so I'm going to go ahead and do this right here. I'm going to just call this, though, temporarily search for order 2. And originally it just had the target or the quantity. Left, right. I don't need an if in this. I don't need to count how many checks. Left, right, middle value, I don't need to worry about. If the numbers dot middle, we don't have numbers, remember, we have orders. So I'll use this guy since it's an array list. And this is less than target, mid. We would do orders dot size here for the far one. And then we reassign left right here. We reassign right here. Or we return mid, or we return -1 if we don't. This all makes sense. So if orders.getMiddle is less than the target, then the new left point is the middle plus 1. So if orders get middle, so if the value at this point is less than the targeted value, which I should change to quantity, is less than the quantity, then our left needs to move forward because it's an ordered list. And so if the value right here happened to be less than the quantity, our left side should then move up to 5, and we should only look at these numbers. Otherwise, if the middle value is greater than our quantity, well then our middle should move down, and we should only look at these numbers. This is all looking good. Let's see if this runs. I'm now going to do it down here. I'll just put a 2 in front of this to show. Oh, middle doesn't exist. We're using mid. This should not be static. I get that just for copying it over. Boom, boom. Same result. So obviously you wouldn't name yours this, but this is a iterative binary search. This would be the recursive version. Both versions work great and are correct. So yeah, kind of up to you. Cool. Onward.